students, this is section 2.1, and in this section it reviews lots of our different types of numbers, and hopefully you have studied most of these, but we're going to do a thorough review of them. So our first set of numbers are our natural numbers. They can also be called our counting numbers, and they are the numbers which of course we count with. And so since they're a set, and let's see if it's going to let me write. Let's try that again. And so I know with the eraser's letting me write. Okay, but the counting numbers are the numbers 1, 2, 3, dot, dot, dot. And they are a set, so we're going to put them in set braces. And in mathematics, we often use shortcuts, and so our shortcut for writing the natural numbers or the counting numbers is going to be to use the capital letter N. For whole numbers, it's again a set of numbers, and they are all your counting numbers. And in addition to that set, also in that set is the number 0. So the only difference between a counting number or a natural number and the whole numbers is the 0, which is in the whole numbers. And the abbreviation for whole numbers is a capital W. The integers are a set, and they are all the whole numbers. As well as all their opposites. The opposite of 0 is 0. The opposite of 1 is negative 1. The opposite of 2 is negative 2, etc. So there isn't a smallest integer nor a largest integer, but they certainly have a nice pattern. And for the integers, I've seen different letters used as a shortcut for them. Not the letter I, though. In Algebra 2, they might use the letter Z. We're going to use the one that I'm most familiar with is the letter J, capital J. The rational numbers, I can't list them because they are the set of all fractions, and it's just impossible to write all fractions. But I can name them because all fractions can be written as decimals. They are the set of all terminating means stop. My T's not coming out so well there. Or repeating decimal, and NO is numbers. And again, I can't list them all because I don't have a smallest one, I don't have a largest one, and there really isn't any pattern I can use. We can also name them by writing them as fractions, so they would be all fractions in this form, A over B, where A and B are integers and B is not equal to 0. And we have to put that in there because if B were 0, we would have an expression that is undefined because we can't divide by 0. And so we have to include that restriction. So again, the rational numbers can be written two different ways. Abbreviation for the rational numbers would be to use the capital printed R. Okay, I'm going to pause as I set up page 2, and then we'll go on. Hopefully you can see this whole page. I know some of it's shaded and some isn't. The irrational numbers are the set of, okay, so my pen's not going to work again. Let's try it again. I'm going to pause. Okay, it's working again. It's the set of all, oh, there we go again, all, oops, non-terminating or non-repeating decimal numbers, and NO is numbers. And there is no abbreviation that is widely accepted for irrational numbers. And of all my years studying math, I've never seen where you want to study just irrational numbers. I suppose we could say the set of all numbers that can't be written as a fraction, but that's kind of hard to say in any other way. So it's better to go with the decimal meaning for it. Ir, again, meaning not. The real numbers are the set of rational numbers or irrational numbers. In other words, it's all the numbers that can be terminating, non-terminating, repeating, and non-repeating decimal numbers. All of the numbers that we study in Algebra 1 are real numbers. When you get into Algebra 2, you will study another set of numbers which contains the reals, but also includes some other numbers, and those are our complex numbers. The abbreviation for the set of real numbers, you can do it one of two ways. You can do this double bar and then an R, or you could just do a cursive R. Either one can be used as a symbol for the real numbers. The absolute value of a number, in this case B, is it's written in this form, and it is the distance that B is from 0 on a NO is number line. Now remember that distance can be 0 or positive. You can't talk about a negative distance. So the absolute value of a number is always 0 or larger. I'm going to pause while I move to page 3, and then we'll continue. Okay, page 3, it says a conditional statement has a hypothesis and a conclusion. Much like you study in science with a hypothesis and a conclusion, the if part of the statement is the hypothesis. The then part is the conclusion. An if-then statement is a form of a conditional statement. It's the one that we will study at this point. In this example, if a number is positive, then its opposite is negative. So this is our hypothesis. So we're assuming that we have a positive number. That has to be true. And if we have a positive number, will its opposite be negative? And yes, it will be. And so that is a true statement. The conditional statement can be true or false. The hypothesis is always true, and then the conditional, the conclusion rather, the part that's after the then, may be true, may be always true, or never true, or sometimes true. If it's always true, then our statement's going to be true. if we can find one example where it's false, then we'd have to say that the conditional statement is false. So here we go. If a number is a rational number, so that is our hypothesis. So we're starting with a number that is a rational number. That means it's a number that can be written as a fraction, or it's a number that's a terminating or repeating decimal number. Does that number have to be positive? The number is positive is our conclusion. And no, it wouldn't have to be, because we could start with the number -1/2. It is a rational number, but it's not positive. So that would be an example, or what we call a counterexample, because it is an example that makes the hypothesis true, but it makes the conclusion false. Third example, if a number is an integer, so we have to pick an integer. So we could pick 2 or 3 or 4 or 0 or -2. We can't pick fractions because integers don't include fractions. So if we pick an integer, is it going to be a rational number? Well, if we have the number 2, is that a repeating or terminating decimal? Yes. Or can we write it as a fraction? Sure, we can write it as 2/1. If we have the number -3, it also can be written as a fraction, or it is a terminating or repeating decimal. So every example that we come up with where the number is an integer, it will always be a rational number. So this one is also true. And once again, our second, that's not writing now. Our second example was false, and our counter example was -1/2. It made the hypothesis true, but it did not make the conclusion true. Okay, I hope this has been helpful, and I'll take questions from it when I see you in class on Friday. So have a great couple of days, and I'll see you soon. Bye-bye.